Hi everybody, this is going to be lessons 18 and 19 together. We're just picking out a few things from each of them. Scale drawings are proportionality in real life. So what we're going to do is just pick out a couple things to do from lessons 18 and 19, and then you know that we're working on our scale drawing project all next week. So for lesson 18, we just want to know, how do you calculate actual length from a scale drawing? So pause it, write it down if you need to. And once you're done, you're just going to look over on the next page, page 79. Okay, this diagram represents a garden. The scale is 1 centimeter for every 20 meters. Okay, you've heard the phrase marking the text, so you're marking the text right there because that's obviously going to be very important. Each square is 1 centimeter by 1 centimeter. So all that's saying is that if these are centimeter squares, then each one of these is 1 centimeter. Another one. Another one. In fact, right now, keep going and trace over and tell me what the length and the width are of this small garden. Pause it if you need time to count. Okay, hopefully you got that this was 8 centimeters and this was 4 centimeters. So that's going to be over here for the length and the width. Now we do want to put in the scale. They told us the scale. So the scale is right here. That's like if you're looking at a map, you see that 1 inch on the map is 5 miles in real life. That's what a scale is. So you think of scales when you think of a map, or you think of a building, you know, like you see a smaller version of a building or a car or a model train. Those are all scales, okay? They're proportionally smaller or bigger. So this one is saying that each centimeter on the scale is actually 20 meters in real life. Now, I know that you can do this, so just pause it. Go ahead and figure out the real life length and the real life width using this scale that's provided, 1 centimeters to 20 meters. So each centimeter on the small one is 20 meters in real life. Pause it, write down your answers. Okay, did you get 160 meters for the length and 80 meters for the width? Hopefully you did, and how did you get that? Write a sentence explaining how you got that. Here's what I did. I multiplied the drawing length in centimeters. What did I do with the drawing length in centimeters? I multiplied it by 20 to get the actual length in meters. So pretty simple, not much to that. It was a nice whole number, so I went ahead and just multiplied by 20. Make sure you have the labels too, though, okay? I don't want you thinking that it's 8 centimeters to 160 centimeters. Each centimeter is 20 meters, okay? So the actual lengths are meters, the drawing lengths are centimeters. Okay, and that's it for page 79. Let's go ahead and look at page 80. What happens when we have fractions or decimals? Maybe the numbers don't work out as nicely. Okay, go ahead and read it and put in for the scale what they tell you in the problem. Go ahead and read it, pause it, and tell me what goes there. Okay, the important things you want to look at is that she needs to enlarge the picture so that 0.25 inches on the scale will correspond with 1 inch on the actual advertisement. Okay, so we've got 0.25 inches on the scale, and we've got 1 inch in real life. Do you know what that multiplier is? If you're thinking about money, you might actually be able to do this in your head. Okay, what would be our multiplier, our constant multiple, or from the scale to the actual? What is it? You can use a calculator, but make sure it's realistic. Okay, what I did for this was I said there's 4 quarters in $1. So I know that it's times 4 because 0.25, 0.25, 0.25, 0.25. That would be one whole altogether. Okay, and now if you look at the small image, we see that this is 1 1/8 and this is 1 1/4. So you can call them length or width. I usually think that length is the longer number So I'm going to put 1 1/4 here. And the width is how wide it is, so I'm going to go with 1 1/8. Okay, use that multiplier of 4 and see what you get. What should the actual lengths be on the advertisement? Okay, did you get 5 inches and 4.5 inches? And then what will the length and width of the tablet be on the advertisement? Let's go ahead and write a sentence about what we did here. We multiplied the scale dimensions by 4 to get the actual dimensions of the advertisement. Okay, and that is actually all that we are doing from lesson 18. So you can do the summary on your own time. In our next class, I'll tell you what problems we're doing, just a few. And then we're only going to pick out a couple things from lesson 19. So if you can flip to page 84. And we're going to go ahead and put in the essential question. How can we identify scale factor? I'll move it down here. And the area of a scale drawing. All right, so we're just going to do examples 1 and 2 here. Pause it if you still need the essential question. Go ahead and figure out the scale factor from the actual picture to the scale drawing in example 1. You should be at a point where you can do that on your own, but of course, all you do is pause it if you need the time to figure it out. You could always, always, always pause it. So if I'm moving too fast, pause it, try doing it on your own. Okay, for me, I see that the shorter side is 3 here and it's 6 here. So I'm already thinking the scale is 6, the original is 3. But I can also prove it using the scale of 8 and the original of 4. Those should be the same number. And that number is 2. Hopefully you got 2. Okay, now let's do the actual area. It's a rectangle, so that makes it nice and easy. 3 by 4. And then the scale drawing actually looks pretty big. What is 6 times 8? If you're good with your math facts, you have that memorized, and it is 48. Okay, we can call those square units so we don't get confused. We don't know if it's centimeters or inches or whatever, but we do know that they are square units, whatever units they are, because area is a covering. I'm talking about how many of those squares do I need to make the rectangle. Okay, now what I want you to do is look at the value of the scale drawing area to the actual area. So remember, scale drawing to the actual drawing. So that means the scale drawing goes up top and the actual drawing goes on the bottom. So the scale drawing area was 48 and the actual was 12. So the actual area is 4 times, or sorry, the ratio of the scale to the actual is 4 times. The area is 4 times bigger. And that's interesting to note because the scale factor for the length and width was just 2, which is different than the actual area. Okay, so you do have to be careful and actually calculate it. A lot of kids want to say, oh, the dimensions doubled, so the area doubles. But we know right here that the area, it more than doubled what we shaded in on the actual picture and what we shaded in on the scale picture. Okay, it more than doubled. It's 4 times bigger. Okay, go ahead and do example 2, the ones that I put stars by. Go ahead and figure out the scale factor and figure out the 2 areas. Pause it and go for it. Ready, set, go. Okay, don't forget for scale factor. If you had 3 as your scale factor, I know what you did. You said that, you know, from 6 to 2, you're multiplying or dividing by 3. But remember, the scale drawing goes on top and the actual drawing goes on the bottom. So the way that I got 2 and 6 was, here's the actual picture and here's the scale. 2 is the new drawing. It goes over 6, 2 over 6. Okay, then let's check it with 3 and 9. Go ahead and write 3 over 9. if you divide those, you're going to get this number in your calculator, and if you forgot how to change that, you can just reduce it and know what fraction that is. It's 1/3. Okay, that's the number I really want you to have, is 1/3. But you do know you can go back and forth between fractions and decimals. I can help you on your calculator if you're not sure how to do that. Okay, go ahead and find the actual area. This big rectangle here, find this area. Did you get 54? And what about the little one? Did you get 6? Okay, so that doesn't seem like it's only 1/3 of the actual area. It seems like it's actually a lot smaller than that. So let's put 6, the new one, or the scale drawing, over the original drawing of 54. Reduce that in your calculator. A lot of you keep dividing 6 by 54, and that's not wrong, but you're going to get a decimal that goes on and on forever and ever. But I just want it to be a fraction, so you want to reduce this fraction, and you'll get 1/9. 1/9. Okay, so the ratio of the scale drawing to the actual drawing is 1/9. So the point of this, though, is to just have you see that when the dimensions change by 1/3 or by doubling, that doesn't mean that the area changes the same way. Okay, in the future you'll go through, you'll see more patterns of that, and in fact, the ceiling tile project that you're going to be working on, we're going to talk about how the area changed from your little picture to the big ceiling tile. So everybody's areas are going to change by quite a bit. All right, so we're going to talk about those patterns again, and that is actually a wrap. That is the whole video for lessons 8, 18, and 19. Okay, see you soon.